Welcome everyone to Limitless Potential Technologies, the series in which we are releasing new clean energy tech, open sourced for you, the people. No patents, no fear, no greed. My name is Spencer. I've spent most of my life researching fringe science, suppressed technology, building devices. I went and got a degree in electrical engineering. I have a background in physics. And like you, I'm sick of being told that this suppressed tech is impossible and not to look into it. So 7 months ago, we set out on a journey. We knew our end goal. The path was unclear, but we had faith. And since then, we've raised over $30,000 for this scientific endeavor. We have a working prototype, a team of fabulous people assembled. We've got people helping us in behind the scenes, and we're getting ready to ramp this up and prove our hypothesis that this clean energy tech is available from the environment. We can harness it, we can integrate our machinery into it, and that modern physics and electrodynamics is in need of retrofitting or revitalization. Today, we're going to recreate a famous experiment that solved one of the greatest problems in the history of electrodynamics and electricity. Is there a connection between electricity and magnetism? How is it related? Then we're going to show you a little bit of behind the scenes of the coil winding, what it takes to turn the raw materials into the components required for our tech. After which we're going to implement these coils onto the machine. We're going to troubleshoot some of the electronics and replace the faulty circuit boards with these new circuit boards. By the end of the video, we will have 4 circuit boards, 4 coils. We will run the machine at RPMs not yet seen on this channel. It's going to be a great video. I cannot wait. Let's get into it and get into this experiment. Over 200 years ago, there was this guy named Hans Christian Ørsted in Denmark. He's preparing for a lecture on electricity. He's going to show electricity flowing through a wire. And by accident, like many great scientific discoveries so often happened, he had a compass near the wire. When he turned the current on, or the electricity flow through the wire, he noticed a deflection in the compass needle. This connection between flowing electricity and the deflection of a permanent magnetic field resulted in us understanding that an electromagnetic field is created when there is electron flow or electricity flowing through a wire. So this internal flow of electricity creates an external field, an external electromagnetic field, and this field interacted with a permanent magnetic field, the compass needle. So let's recreate this, okay? Let's get our wire, and we're going to connect either end of the wire to our power supply. So we have both ends of the wire connected to the power supply. We've got our compass beneath the wire, and you can see that when we turn on the power supply and amperage flows through the wire, that the compass needle moves, is deflected. So again, off, on. That's how Hans discovered this. He had a compass needle in the vicinity of a current carrying wire, and he noticed the deflection happening to the needle when he turned on the electricity flow. Let's take 3 compass needles and see the effect. Same thing, you can see the deflection because of the external electromagnetic field that we are creating due to the internal flow of electrons. The electricity inside the wire is creating an external electromagnetic field. We've just done this with a single wire, so we recreated his experiment. How do we amplify this effect? How do all of our modern motors and generators work? Well, if we take a single wire and we coil it again and again and again, that amplifies that electromagnetic field outside of the wire. This coil of wire, if we put electricity through it, a flow of amperage internally within the wire is going to create an electromagnet outside of the coil. So let's demonstrate that. Let's hook up our coil to the power supply. Let's place compasses all around here, and we will demonstrate the electromagnetic field that is created when you put electricity through a coil. So again, let's energize the coil. You can see all of the compass needles are now being deflected. The compass needles on this end have their north poles pointing towards this end of the electromagnet, so that means we're forming a south pole here. And on this end, the south poles of the compass are being attracted. So we've got a north pole on the electromagnet here, a south pole. So you can see on our indicator, we got a south pole there and a North Pole there. So we verified with this magnetic field testing device what we're seeing here within the compass needles. Now, one final thing I want to demonstrate for you is we've got some iron filings here. Let's put this close to the electromagnet we've created. You can see these circular lines within the iron filings forming. So that's the flow of magnetism creating a closed loop, south to north, north to south, and then you can see it flowing out the ends here. But basically there's large loops of electromagnetic field being created. If we lay this down here, you can see the circular paths that are created in these iron filings by the electromagnetic field that we've created within this coil by passing electricity through it. So let's turn this off. You can see the compass needles going back to their original orientation. So Hans Christian Ørsted's famous experiment we have now recreated, and we're showing the ability of a current carrying wire to produce an external electromagnetic field because of the internal electron flow within the wire. This electromagnetic field that we're creating has the ability to interact with other fields, a permanent magnetic field outside. There is no change to the internal flow of electrons due to the interaction of those two forces. So we can do work on this compass needle, which is what we did there. We did a positive work. We increased the kinetic energy of the compass needle because of the electromagnetic field pushing on the magnetic field of the compass needle. So that's positive work. It increases kinetic energy. You can do negative work as well. Negative work decreases kinetic energy. So let's just keep those two things in mind, and that experiment we just did, it's going to come into play near the end of the video and is the basis for this pulse generator and all of our modern motors, generators, and electrodynamic machines. So that was pretty cool. I like doing those little experiments. Hans Christian Ørsted often spoke about intuition and that being a part of science, a fundamental part of science, and you know that's what we're all about here on this channel. So thank you, Hans Christian Ørsted. There's a shout out to you. 200 years later, we recreated your experiment. Let's get into winding coils. We got to upgrade our coil holding device, so let's do that now, then we're going to get out in the field. So now we need to wind some wire out in the field, but these spools of wire that we have here are 30 kilograms. So it's just plastic rubbing on steel, and you know, 70 pounds on there. The friction is substantial. We got our hybrid bearings from China. Put these bearings in there that should reduce the friction.
You can see that one is somewhat in there.
We've got our empty spools. The next problem we face is the field that I've been using to wind my wires in is now occupied by children during the daytime because it's an elementary school across from my house. So I am in search of an alternative solution, which I think we have found. You guys take a look at this field. It's a public field that's used for soccer and football, but usually not till the evening. So this is the parking lot here. I'm the only one in it. Perfect. I think this is going to do nicely. So let's get out there and pace out 250 feet. So we found a suitable field. Next issue is measuring out 250 feet up to this fence here. So that's what I'm going to do now. Pace out 250 feet approximately. This is a 25-foot. We are now walking out 10 lengths of 25 feet for a total of 250 feet between either end, which we attach to the fence. We got everything measured out. Let's start pacing out some wire before there's too many people playing soccer on this field. Some of you have seen me do this many times. For those of you who have not, we're going back and forth at least 8 times if we don't screw anything up. Every time back and forth is 2 to 4 minutes, so usually 30 to 40 minutes of walking and pulling wire per coil. So we got our 8 strands out. Now one critical step, definitely tape the wire as soon as you're done with it. Having these spools
unwind to become loose is not ideal in any way. So make sure you take care of that.
Our next problem, we need to tighten all these wires so they're much closer together, so when we go to wind them, everything is equal lengths. So to solve this problem of the wire needing to be tight and equal lengths, first we're going to start on that end, and we're going to make it so that when it is nice and tight, we have the ability to connect the drill on that end and twist it together. If you have to cut it without getting the drill connected first, then everything just goes loose and it messes up. So I've been there, trust me. Put a knot in this end. Now we can go back to the start and tension all the lines. Then once we get tension on all the lines, we can go back up to that end and hook the drill in and start twisting. That's the plan. Let's go over here to this end and get everything. I want to take each individual strand . And I just kind of tension it like that, so they're all equally tight. Pretty close. This one here could use a little bit more. That looks pretty good. I mean, they're not exactly all the same height, but they're much closer than I'm used to. Solved the tension problem. We're on to the keeping them off the ground problem, which we've done before, solved before with our tower. Let's build the tower, let's twist these things together, and let's get the heck out of here before there's a soccer practice. Now we're taking pieces of wire and we're just making loops to hold all of the strands together. This is actually one of the better techniques that I've figured out to keep everything nice and tight. And we do not want the enamel coating to rub off on our brace, our stand here, our tower, so we're protecting it with a piece of cloth. Guys, this is looking great. We've got our line pretty close to being done twisted. I'm gonna get another 30 seconds on the drill twisting. That's solved, and the final problem to solve is how to get the line from here to back into the shop where we can spool it onto the lathe, onto the final spool, the final coil. We're gonna put it on this temporary spool. This is the final result of all that work. We got one nicely wound spool. I'm happy with this one. Easier said than done, I'm picky. We're back in the shop and we've got successfully wound wire onto our temporary spools, twisted together, 8 strands, 250 feet long. We managed to beat the soccer practice in the field, and now we need to go from this spool, temporary spool, onto our permanent 3D printed coil cores. So this is the final resting place of our mag wire twisted together, our oct-fuller wound mag wire, 8 wires twisted together. If we were to just wind it directly onto here without bracing the ends, there's the potential for it to bow, these ends to bow outward. There's a lot of pressure when you're winding. In order to prevent that problem, that issue, we're gonna take our metal bracing and we're gonna attach it on either end of these coil cores, put the rod through the center, get everything tightened together. That's going to prevent it from bowing outwards, and that's going to also allow us to spin it on our lathe here. Now we have our metal channel iron bracing the ends, preventing it from bowing outward. We have the ready rod through the center, which allows us to put this on the lathe. The final thing we need to do is we need to drill a hole so we can feed the one end of the wire strands out. And we'll feed our wire ends from the inside out. And we want to bring out at least 3 or 4 feet of wire. And remember, we're also going to put a little piece of electrical tape
over the wire where it goes through the metal hole, just because there's sharp edges and we don't want anything rubbing. There, we just feed that through so it rests nicely. Then we're going to spool up the rest of this. Spool's mounted, coil's in place. We got our extra wire through the side, through the hole, sitting nicely in here, and this guy is ready to spin. So the next problem we're solving is getting this wire onto this coil as perfectly symmetrical as possible, neat, tidy, which is a lot easier when you wound and twisted these 8 wires together properly. I'd say at least once per video I forget to turn the microphone on, and that's what's happened here. We're finishing up winding the coil, and now that we've got the coil complete here, we're going to apply the epoxy. This is satisfying to do in person and to watch. It's the final step. The coil looks beautiful. The epoxy makes it look even better. Cannot wait to get this thing off the lathe, which I'm doing here. And you'll see we move the tape, and there's a little strip that still needs to be coated in epoxy. So we're going to finalize that, finishing the power coil and encasing it in epoxy. Now, we're going to switch over to the generator coil. You're going to see the spools of wire coming up next. This is a 27 gauge wire, and then this is a 30 gauge wire. We've gone with the 27 gauge wire, which is approximately 0.4 millimeter diameter for this generator coil. I'm setting it up here, same as we did the power coil, securing it between 2 pieces of channel metal, channel aluminum, drilling a hole through the side so that we can run the wire through it, remembering that we need to protect the wire from the metal with a piece of electrical tape as we feed it through. You can see it here. We've got our spool of 27 gauge wire, a 30 kilogram spool in front of the lathe. We're mounting the coil to the lathe, and we're going to feed it on to the coil here. One thing you can note is that I did not change the speed of the lathe from the power coil. So it starts up very fast here on me and gets out of control. This is regular speed, and this is how fast it went when I kicked it off. I tried to see if it's going to work here, and it does not. So we redo it, we cut the wire, and we start again. We're finished our generator coil, at least to the extent that I want to go with this one. Key thing here, we're going to take a piece of tape. There we go. So now we can apply the epoxy to this side. We'll get everything set in place. Let it set up. Honestly, that had to be an hour straight of standing there winding the spool. I thought the gen coil would be easier than the power coil just because it's a single core. Nope. Way harder. So anyways, at least that makes me like winding the power coils that much more. Our power coil's there. Let's just get that guy set with the side that we still need to finish here. So we'll finish up this power coil side there, and we're going to get our gen coil onto the paper as well, the drip area. I don't know, we'll do it somewhere there. How about that? There. So now we can put a coat onto our gen coil and our power coil. Shout out to JB Weld too. I did reach out to them a few months back and asked them if they would sponsor the channel. They were going to give us a bunch of free product, but since we're in Canada, they weren't able to. They would have though if we were in the US. So thank you, JB Weld. You guys make amazing epoxies and products. Get a nice coat onto our generator coil here so it can set up overnight, and then I can take the tape off in the morning.
So today, you guys, we have a sponsor. You may have noticed this beautiful standing desk that we have all of our hundreds of pounds of copper wire on it. This is from FlexiSpot. This is an Easy 7 Plus standing desk from FlexiSpot. FlexiSpot is an American-made company. They make the world's highest quality standing desks. This thing's capable of lifting over 500 pounds. Right now we have 250 pounds on there. That was no problem for it. You can see it's got 4 square metal legs, square tubing, super high quality. Most desks, stand-up desks that I've tried just have the 2 legs. They don't lift more than 200 pounds. Right now it's at 52 inches. Most desks only go to 46, so extremely high quality. They have lots of different sizes, models, beautiful desk. If you guys are in the market for a standing desk and you want the highest quality American made, check out FlexiSpot. The link's in the description. Thank you so much, FlexiSpot, for sponsoring today's video. It means the world to us. We love partnering with high quality companies. So thank you very much for the standing desk. We're gonna make it into our coil winding 3D printing area. You guys, check out FlexiSpot, link in the description. That was a lot of work, you guys. I'm sick of winding coils. I hope you enjoyed the video. It was kind of a long section there. This will probably be the last video where I show all the coil winding stages, so I wanted to do it properly, start to finish, how I'm currently doing it. This is the end result, a beautifully wound, octafilar wound coil, power coil. We're gonna have to drill out some mounting holes here, and we're gonna get this guy mounted in the bottom position there on our machine. So that's the next thing, we're gonna get to it. We've also produced a beautiful generator coil, which in the future I will show you the filling of the coil core with our soft iron core material to concentrate the magnetic flux as best as possible without too many losses. We're gonna go into a couple secret little details about how we're gonna negate losses within these coils later in the video. Also, thank you to Fred. We've had somebody reach out who has manufacturing capacity in Hong Kong, and he's offered to wind coils for us, produce boards. Thank you so much, Fred. This is honestly the exact thing we needed. Like, couldn't have been more aligned from the universe and come to us. It's just perfect. So he's gonna wind coils. I'm surprised he's able to do octafilar coils, but no problem, he says. So he's gonna wind gen coils, power coils, produce boards, and that'll allow us to produce them in large enough quantities that you guys can have access to them too at a reasonable cost. So if you're interested in that, shoot me an email. That is something we're thinking about. A lot of this stuff that we're building is pretty, it's skilled, it's time consuming. If you have the ability to purchase it at basically cost, then why not? I mean, if I did, I would. So that's something we're gonna offer in the future. Thank you, Fred. It's gonna speed up this build. The mounting holes we have here for the coils are 50 millimeters apart, and then our overall coil width is 78 millimeters. So if we make a line, we'll take 78 minus 50 is 28. So we'll go 14 millimeters from either end. We'll make a little mark, go 14 millimeters from either side, and center these lines like so, these marks. There, now we've got the holes drilled. We can mount our 6 millimeter machine screws. Now we're ready to mount this coil. So we still need to check that there's been no wear through on the enamel coating and that all of these wires are independent. There's no conductivity between the wires. So technically I should do this before winding the coil and epoxying it, but I'm confident that so we've got the ends of our coils exposed, bare copper wire. Let's turn on our multimeter here. And 3.87. So you can see only one of the wires conducts 3.84 ohms. So that's what we want. We do not want it conducting on multiple different wires. That would mean that we've rubbed the enamel coating off. So 3.72 3.6, so you can see all the wires are roughly 3.5, 3.6 ohms of resistance. Be careful if you're touching both ends with your body, then it'll go through your body and measure your internal resistance. 3.6, so say 3.6 ohms of resistance for each one of these wires. No continuity between them, that's a big deal. We do not want continuity. So for all of you out there interested in the inductance, 2.4 millihenry of inductance in each wire and 3.6 ohms of resistance. So there's your R and your L values. Frank, shout out to Frank. He's done over 100 comments on the channel. We love you guys. Thank you all for commenting and being part of this community. Let's mount the coil.
We're going to mount a coil inside our machine here. You can see me putting it in the bottom. This is why there's no solid front to the machine, so that we have access to all of the components to remove and install as needed. We're going to put it in place so there's a 1 millimeter gap and secure the back, and we are done. Coil is mounted.
We're going to mount one of these beautiful boards that we've gotten from Joe. Look at this masterpiece. We have now successfully changed the optic sensor to our new Panasonic optic sensor. We've got 4 boards mounted, connected. We've used the right-hand rule, which you will remember from our last video. You put your fingers on the right hand in the direction of conventional current flow from positive to negative, and this allows our thumb to point towards the North Pole. So that's what we did to figure out which wires needed to be connected to the negative and which wires connected to the positive, so that there will be a resulting North Pole on the face of the magnet here, the face of our electromagnet, which we just wound, and you guys have seen me wind and everything that goes into that. The final thing we're gonna do is we're gonna put on our safety glasses. I've got all the batteries disconnected right now. A note on connecting batteries: always connect the negatives first, and when you disconnect, you always take the positives off first. And that's just in case anything goes wrong. You always want a path to ground for things to discharge through. And with this machine, we always want to connect the charge battery bank first, negative, positive, then the run battery bank. And again, that's just to protect the electronics. Even though everything's switched off, just in case anything discharged for any reason, we always want the charge battery bank hooked up as well. We've got power to our optic sensor. You can see it is working. And we've timed it. So if everything's right, we've successfully used the right-hand rule. We should be able to turn on our new board and have it create a North Pole and repel the northward out, or the outwardly north facing, I don't know how to say that. The mono North Poles on the rotor are going to be repelled by the electromagnet's North Pole that forms on this face. Shall we try it? We've got all the individual circuits off on the boards. We'll turn on the main power. So now you can see we have power going to all of our circuit boards. All of our switches are off on the boards. And with the direction and the way we have the timing, we've got to spin it this way so that when it's just past top dead center, it fires. So if we give it a spin, now I can hear it firing. If we've got it hooked up correctly, it's going to start to increase in speed, RPM, which it is. So that means we've got it to turn on all 8. Coil that we wound, it is creating an electromagnet. The internal flow of electrons or electricity is creating an external electromagnetic field. Now, we're only utilizing the North Pole currently for repulsion. That is not the most efficient thing we could do. If you remember our iron filings from yesterday, so this showed that there was a North Pole on one end and a South Pole on the other end. The South poles that are being created here are not being utilized. We can do work with that force as well. So using both ends, the south and the north pole, would be much more efficient than the monopole setup. We get this thing working, it's producing excess energy. There's still many, many ways to increase the efficiency, right? We could mount the coils so that both ends, the south and the north, are being utilized to produce work, positive work. That's what we're doing here. That pulse is creating an increase in kinetic energy of the rotor, which is positive work. That's one board. Let's take a quick reading with 178 RPM. We're spooling up. That's a single board. Let's turn on all 4 boards and see where we're at. We'll let it spool up. I know that's what you guys want. Me too. So let's switch on this board here. $319, $325. I would think it'll hit between 700 and 800 RPM. We'll take our voltmeter and we'll put it on the charge battery just so you can see it charging. Charge battery, we're currently at 25.43. And we're at almost 400 RPM. It's going to be a lot easier to do this once we have the timing circuitry, which is coming next. We'll be able to modify the duty cycle and advance and retard the timing or the trigger signal. Basically, by the end of October, early November, we're going to have the high voltage power supply, the battery flip-flop, and the ability to modify pulse width, modulate the duty cycle, so the on-off time, and advance and retard the signal, depending on where we want it to fire, based on the position of the magnet on the rotor. Once we've got those 3 components, it's going to get exciting. We're going to be able to monitor the input and output voltage and amperage, and then we're also going to be able to monitor the charge on each battery bank, a Coulomb meter, so we can see the charge, the amount of energy in either battery bank, the amount of energy coming in and going out, the RPM, and also the work that's being done on the conventional gen coils that we're going to put on here. We're at 500 RPM. Charging battery bank is at 25.45. Running nicely. And again, we are not saying that we're going to get more conventional power out than in. What we're saying is we're going to get more electricity because of the high voltage spikes going into the battery banks. Excess energy will flow from the environment into the battery banks. How is that possible? Well, there's energy in space. Literally, inner space are the micro components in between atoms, the space in between everything on a small scale. There's energy there. Outer space is the macro, large space. So we're saying that from inner space, excess energy will flow because of the dipole that we create in the battery when we slam high voltage spikes from the magnetic field, the electromagnetic field that we've created by passing current through these wires, shutting off the current. That collapse causes the electromagnetic field to produce a high voltage, a flyback voltage that is fed into the charge battery bank and creates a dipole. That's where we're saying we're getting the excess energy. And our charge battery is 25.51. We can take some measurements with this amp meter, but I mean, they don't mean much. It just shows discrepancy. So for example, this second board that we just put on here, this is the charge battery negative, so negative 0.3. So it's 0.33, and then the run battery negative is 0.4, charge battery positive is 0.25, run battery positive is 0.4, this one, the charge battery, or sorry, this is the run battery negative, 0.46, and the charge battery 0.46. So the negatives on this one show the same amperage in, same amperage out. Obviously the battery voltages are slightly different. And the positive out shows 0.26, but then the positive in shows 0.26. So this new board is showing basically the same in as out. Let's zero it again. So we're zeroed. So this is our positive in, 2.7 positive in, and then positive out is the same. And the negative in is 0.45, and the negative out is 0.45. So that's interesting. I think these other two boards, the older ones, basically have some MOSFET drivers that aren't firing correctly. I got to troubleshoot them. But that new board, I mean, it's showing on the amp meter as best as we can see. It's not 100% accurate, but basically the same amperage going in as going out. So very efficient at the least. And they're slightly different voltages, so the wattages aren't quite the same, but bear with me, right? It's still cool measurement. Back down to one coil, just with the new board, just one, our brand new coil that we wound to the new board. I just want to show you guys these measurements. So on the charge battery bank, we have 25.52 volts. On the run battery bank, we have 24.48 volts. Now, with this amp meter, we can zero it out, which we will do. So we've got it zeroed out. This is the positive in. So the input is fluctuating between 0.72 and 0.8. The positive out is fluctuating between 0.6, 0.63, 0.67, 0.6, 0.7. The negative in is at 1.4, 1.5, fluctuating. The negative out is at 1.3, 1.2, 1.3, 1.4, fluctuating. And then let's use our other Finsbury meter because I can actually get this one around the mains of the cable. So this is the power in battery. And again, this thing doesn't have a zero function on it, so it is what it is. So that's the amps in on the positive. So we've got 3, it's fluctuating, but you can see the amps in, 0.2, 0.3, and then this is the negative in. It doesn't show any amps for the most part. And then negative out, 0.2, fluctuating between 0.2, 0.6, 2.6, it's fluctuating. And then the positive out is 2, between 2 and 3. So again, let's turn this thing down again. Interesting measurements. We definitely need better data logging equipment and the ability to measure the overall potential energy in the system, everything in and out. We're getting there, but interesting measurements. The machine's very efficient for sure. This whole machine works on these principles that we demonstrated in the beginning. We showed that when you put an electric current through a wire, there is an external electromagnetic field generated from that internal flow of electrons. When we have a electromagnet like the coil that we wound, and we have a north pole on this end and a north pole on our rotor. If we pulse it, if we put electricity through it and we cause this north pole, when the magnet is past this position, then it's going to push it away. So it's going to induce a counterclockwise motion. The same thing can be done if we do the opposite direction of flow through the coil. We could produce a south pole on this end and pull this north pole magnet towards it. So both of these cases are going to produce a counterclockwise rotation on our rotor. Both of these situations are producing positive work. They are increasing the kinetic energy of the rotor. They're doing this by the external field produced from this electromagnet interacting with the permanent magnet field, okay? You can do as much positive work or negative work as you want. You can interact those two fields externally, the one outside the wire and the one outside this permanent magnet, without affecting the internal amperage flow in the wire. So remember that. If I wanted to do positive work on this side of the coil as well, if I put another rotor up here and interacted with the south pole when we were generating the north pole down here, it doesn't affect the current flow. It still requires the same current flow. You can double the work. That's another way we can get, in the future, more energy from these systems. Monopole molders are definitely not as efficient as using both sides of the coil. So what is negative work? Negative work would be if instead of firing in this position, we fired a north pole magnet before this approaching north pole past top dead center, then we would be repelling and decreasing the kinetic energy, slowing down the rotor. This is what happens in all of our machinery, generators, motors. There's negative work being done. They call it back electromotive force. A flyback voltage is another form of this. Negative work is not beneficial. So in these systems, what we're doing here, this timing, everything that we're working towards, is to maximize the amount of positive work we're doing and to negate the negative work. So we're doing that with instantaneous pulses. In the last video, I left you with an open-ended question. Why is repulsion mode, so when we're firing in this configuration with the north pole repelling the north pole, why is it more efficient than firing in attraction mode and pulling the north pole towards the south pole? This is what's going on. When we put like poles together, you're compressing the magnetic lines of flux. Magnetic lines of flux are compressed with like poles repelling one another, and when you put dissimilar poles together, they connect, they complete circles. So we can see that. There's less density of these field lines when the poles are completed. So the flux density in repelling poles is more than in the dissimilar poles attracting one another. So there's a sharper gradient created with a repelling magnet versus an attracting magnet. So that is why repulsion is more efficient than attraction. So our generator coil, this guy here that's going to have an iron core, we are going to negate negative work with it by having the circuit open. When the magnet is approaching, it's going to be attracted to the iron core that's within the coil. And then right just for a couple degrees of rotation, we will close the generator circuit, discharge the built up pressure or voltage that's in that generator coil, collect the amperage, and if we time it correctly, I believe we should be able to increase the kinetic energy and do positive work at the same time on the rotor. This is how Robert Adams' motor worked. So we're taking bits and pieces of all these amazing previous inventors, the Adams motor, the Mueller motor, Bedini motor, all of these different systems, and we can take all of the best parts and revitalize it and create our own system with it. Overall, the principle in this system and any system like it should be and is to increase positive work and decrease negative work. We want to increase the kinetic energy with the field-on-field interaction outside of the wire from the internal flow of electrons that create that external electromagnetic field, and it interacts with the permanent magnetic field on the rotor. That's the whole point. People say this is breaking laws, man-made laws, and that's not necessarily true. Maybe in some situations, but that just means that those man-made laws were likely derived with incomplete data sets, so incomplete analysis of the information in the system. So they didn't have enough information, they construed or misunderstood the information in the data that they were gathering, so it resulted in incorrect formulation, right? They formulated the data coming in incorrectly. So it doesn't mean we're breaking nature's laws, just incorrect man-made laws. Thank you to everyone. I hope you understand negative and positive work and how there is an external field created from an internal flow of electricity in a wire. This is the same as us. We create the external from the internal. Have faith, move forward, take action, and I will see you soon. This has been Limitless Potential Technologies.